Welcome back, friends. Please remember on this channel I post videos on different math concepts and so on, but usually at a more advanced level. So here we have a nice integral that goes from 0 to 1 of ln of x plus 1 over x squared plus 1. Okay, we're going to do a couple substitutions, not obvious ones, but it'll get us to the value of the integral at the very end. So we'll say that x is equal to, let's see, tangent of theta, which is, of course, sine of theta over cosine of theta. Now differentiate this so that dx over d theta here. So differentiating this, you can use the quotient rule. You're going to basically end up with something like 1 over cosine squared theta, which can be recreated as 1 plus, let's see, tangent squared theta. Okay, you can check this if you work through some of the identities here. Okay, now notice when x is 0, then the lower limit that is, right? So when x is 0, you have 0 is equal to tangent of theta, but that just, of course, means that theta itself is equal to 0. And when x is 1, then you have 1 is equal to tangent of theta, which of course means that theta itself is equal to, let's see, pi over 4. That's a 4 right here to be clear, right here. Okay, so now we can recreate the integral. So our integral I is equal to the following integral from 0 to pi over 4. And then this becomes, let's see, ln of x plus 1, but x is tangent, so it becomes tangent theta plus 1. And then in the bottom, you have x squared plus 1, but x is tangent, so it becomes basically tangent squared theta plus 1. And then, so here, since we have dx over d theta equals this, then put the d theta here, right, and then remove it from here. So dx can be replaced with this expression from here. So that's going to give us here 1 plus tangent squared theta with the d theta. And of course, the nice thing is now look, right, this cancels with this. And then that's going to leave us with I being equal to the integral from 0 to pi over 4 of ln of tangent of theta plus 1, like that, tangent of theta plus 1 with the d theta right here. Okay, now we have to work through this. So how can we do that? We're going to make another variable substitution that will allow us to do that, a common trick. So in other words, we're going to set the following. Let me write that down here. We're going to call u equal to pi over 4 minus theta. Why? Because this will allow us to create this tangent of theta here in a more useful form. That's why. So now differentiating, we're going to have du is equal to, of course, negative d theta. Okay, what else do we have to do here? We have to switch the limits of integration. So, all right, when theta is equal to 0, we're going to have u becoming pi over 4. Okay, and then when theta is equal to, let's see, the upper limit of pi over 4 right here. So this is pi over 4. Then u would be equal to 0. So let's see. Yep, now we can recreate our integral as follows at this stage then. So basically I is equal to this integral. Okay, so let's be careful. When theta was 0, then this becomes now pi over 4 down here, right? And then what was originally pi over 4, now this becomes a 0 up here. And now the integrand, you're going to write as ln, and then tangent of theta plus 1 tangent of theta. You're going to write this as tangent of, well, you got to solve this for theta. See, there's always a bit of an extra step. Solve this for theta, so you're going to do, move the theta here and then do pi over 4 minus u. Theta is equal to pi over 4 minus u. Okay, put that in here. So pi over 4 minus u with the 1. Okay, be careful with all the brackets. And then let's see, negative. So this is d theta, this is du. So move this here, make that positive. So it becomes negative du. Okay, this is what we have thus far. Again, we don't like these unnaturally sequenced limits here. So let's flip them. So this is going to be from 0 to pi over 4. Okay, flip these, right? That gets rid of the negative. So we have now ln of tangent of pi over 4 minus u with the plus 1 with the du. At this point, this quantity here can be replaced with a basic identity tangent of pi over 4 minus u. So well, you know what, before we do that, let's do that. So tangent of pi over 4 minus u, let's replace that as follows. We have a nice identity that says tangent of pi over 4 minus, let's see, what was the next stage here? Tangent of u this way. Okay, and we place this over 1, and then it says plus tangent of pi over 4, and this is another tangent of u. Clean this up a little bit here. So this is going to be a 1 minus tangent of u. Okay, and then in the bottom, this is again a 1, so it's 1 plus tangent of u. Now we have to replace this part with this part and then manipulate that a little bit more. All right, friends, so we're going to have I is equal to this integral from 0 to pi over 4, and then just rewrite that as the ln. So here we have to be kind of careful. I could put a giant bracket in there. 1 minus tangent of u, and then 1 plus tangent of u, and there's a positive, let's see, a positive 1 right here, right? We have to account for. So plus 1, and then at the very end we had basically du. Okay, so we'll just leave it as I, and I worked with this, so it's going to be the integral from 0 to pi over 4 of ln. Now what happens within, right, this green bracket? Well, you got to have 1 plus tangent of u multiplying over to the 1, so it's going to give you 1 minus tangent of u plus 1 plus tangent of u, right? And this whole thing hanging over that 1 plus tangent of u with the du out here. So let's see, cancel what we can. Okay, so anything, yep, like this will cancel with this. That's going to leave us a 2 in the numerator and the side ln. So I is equal to the integral from 0 to pi over 4 ln. Okay, and now we're going to have a 2 over a 1 plus tangent of u du. Okay, continuing down below, so I is equal to the integral from 0 to pi over 4 of just ln of 2, and then minus the integral from 0 to pi over 4, right? By the basic rule for logarithms, right? This division symbol becomes a subtraction, then you distribute the integral operation, so you're going to have, let's see, ln of 1 plus tangent of u du this way. Okay, so you put a du in here also. So finish this up. I is equal to, well, this part here, we know that's just, simple integration. It's going to be ln of 2 over 4 times this pi from the top. So that's a pi, say, out here. ln of 2 pi over 4. That second part, though, look, right here. All right, look, in green, let me highlight this in green. That's just another form of I. Somewhere from, let's say, right here, isn't it? You see, this is theta. This is u, but it's not important. Those are just letters, so it's just I. Okay. So that's I. Then you just move this over to here. So you're going to have 2I is equal to ln of 2 pi over 4, which lastly then tells us that I itself is pi. Let me make this smaller. Ln of 2 over 8. And that's the definite value of our integral. Well, that is it for this one. Please be sure to subscribe and like if you like more advanced math videos like this one.